This is the second part of the video lecture for Math 110 for Wednesday, April 22nd. And again, the topic today is the law of sines. In this second part, we're going to solve two example problems. The first problem is solving this triangle. Now, a triangle has three sides and three angles. So there's 6 attributes of a triangle total. You have to know 3 out of the 6 to be able to solve for the rest. And we know 3 here, so we can solve this triangle. But the question is, and we're going to use the law of sines to do this. The first step in solving this triangle is to label the different sides and lengths of a triangle. And so I'm going to label this side A and this side B. Okay? And that means this is angle A, this is angle B, this is angle C, and this is side length C. Now, which side you choose to be A is arbitrary, and it's okay to have some variety there, but you do need to be consistent. So if I label this side A, then angle A is the angle that's opposite side A. Angle B is the angle that's opposite side B, and so on. Okay, now I can attempt to solve this triangle. The first step in solving this is we can actually solve for angle B because we know that the angles of a triangle add to 180 degrees. Okay, so we can use that fact to find angle B, which means B will be equal to 180 degrees minus 50 degrees minus 45 degrees. So 180 minus this angle minus this angle. And this gives us angle B. And it turns out angle B is 85 degrees. So indeed we have a non-right triangle. No angle in this triangle is 90 degrees. We need to use the law of sines. So I've just found angle B. And then I can use the law of sines to solve. We need to solve for side A and side B. So the way this works is we find an angle side pair where we know both the angle and the side. Now this pair here, we know both the angle C and side length C. So I'm going to use the law of sines, which says, let's write down the law of sines again. Sine of A over A equals sine of B over B equals sine of C over C. So now I'm going to use this part. Sine of C over C is sine of 50 degrees, okay, over side length C is 12. And now I'm going to pick another pair like A, angle A and side A. This equals sine of angle A, which we know to be 45 degrees, right? Divided by side length A. Now I don't know side length A. So now I have an equation where I have one unknown, and I can solve this for A. And one way you can solve it, there's a number of ways you can do it. You can cross multiply. So this means A sine of 50 degrees equals 12 times sine of 45 degrees. Okay. And then you can divide both sides by sine of 50 degrees. Okay, and these cancel out, and you get A. This means A equals 12 times sine of 45 degrees divided by sine of 50 degrees. Okay. So now we've got an equation for A. Now we plug this into our calculator. One note here, be careful, these angles are in degrees. Make sure your calculator is in degree mode and not radian mode to get the correct answer. If you plug these numbers into your calculator, you guys will get 11.1. So side length A is equal to 11.1 in length. And now the only thing left to find here is side length B, and we're going to do that. Now, I mentioned to you guys you could use this version of the law of sines, or you could invert the whole equation and use that version. I'm going to use the inverted version, okay, which goes like this. A over sine A equals B over sine B equals C over sine, C, sine C. And now I'm going to take any pair I know, like let's take, now I've just found angle A and side A. So now I know 11.1 divided by the sine of angle A, which is 45 degrees. Okay, let's go to angle B and side length B. This equals B, which I don't know, divided by the sine of angle B, and angle B is 85 degrees. Okay, so I get this equation. I have just one unknown, and I can solve for B. The easiest way to do that is if you multiply both sides by sine of 85 degrees, okay, which is totally legal. Okay, these cancel out, and you get B equals 11.1 times sine of 85 degrees divided by sine of 45 degrees. And if you plug this in your calculator, you get 15.6. So side length B is 15.6. Okay, one last step here. Let's check the reasonless of our answers here. It looks like side length B is the longest side, and that is in fact true. And in fact, the bigger the angle, the longer the side opposite that angle. So it makes sense that side length B is the largest because it's opposite to the greatest angle. And then side length C is smaller than that, but then A is the smallest because it's opposite to the smallest angle. So a little reasonableness check here. These answers make sense to us. So this is example 1. Let me do one more example with you guys. Okay, by the way, that last triangle, if you want to know, it was an Aas triangle. And don't get too bogged down in that, but there's different types of triangles. Aas is one where you know an angle, and a side. This example is an SSA triangle. Okay. And let me draw this example here for you guys. This is example 2. Okay, we have this triangle here. Okay, and this side length is 20. This side length is 17.5. And I know this angle is 57 degrees. Okay, that's my triangle. Okay, now this triangle is what's known as, the last triangle was an Aas triangle. This triangle is known as an SSA triangle, meaning we know two sides. We know this side, and we know this angle. So in this case, we know two sides and one angle. We need to solve this triangle. Again, the first step here is to label our triangle. And so I'm going to label this angle A, okay, which makes this side A. I'm going to label this angle B, which makes this side B. And then this will be angle C, and this will be side C right there. Okay, and again, I'm going to use the handy-dandy law of sines to solve this triangle. And the first thing I can do is try to solve for angle B. Now, I only know one angle here now, so I can't use that old trick of 180 minus two angles because I only know one angle. But what I can do is I can try to solve for angle B. And so I'm going to use the law of sines, which says sine of angle B divided by side length B, which is 20, is equal to the sine of angle C divided by side length C, which is 17.5. Okay, and by the way, I know angle C. I'm sorry, I know angle C is 57 degrees. Okay, and then I'm going to solve this. I have one unknown. I'm going to solve it for the sine of B. If you do that, I'll save you guys the arithmetic in doing that. But if you solve this here, you get sine of B equals 20 times sine of 57 degrees divided by 17.5. Okay. Now here, I know the sine of B equals this, and you can calculate this number. And this number is actually 0.958. Okay, 0.958. Okay, but I want to find angle B, not sine of B. How do I find an angle B? If I have sine of B equals this number, how do I find the angle B? The answer is I have to do the inverse sine. So B is equal to the inverse sine of 0.958. And we talked about inverse sines in the last class. Take the inverse sine of 0.958. If you guys plug this in your calculator, you get an angle of 73.4 degrees. So that is angle B, is 73.4 degrees. Okay. By the way, on your calculator, to do an inverse sine, you have to hit the shift button and then sine. And that'll be typically inverse sine, the button above that. Anyway, you guys can look at your calculator and figure that out. Be careful, you're taking the inverse sine, not the sine. Okay, this is angle B, so we know this is equal to 73.4 degrees. Well, now we can find angle A, because now we have two angles, so we can find the third angle by using that 180 trick. So angle A will equal 180 minus 57 degrees minus 73.4. And if you guys plug this in your calculator, you get 49.6 degrees. So now we know angle A is 49.6 degrees. Okay, and that just leaves us with one unknown, which is side length A. To find side length A, we're going to use the law of sines again. We're going to use the inverted version of it. And so what I can do is write A divided by, so side length A divided by the sine of A, but I know angle A is 49.6. So A divided by sine of 49.6 is equal to, pick your other favorite pair of sides, is equal to side length C, which is 17.5, divided by the sine of angle C. And angle C is 57 degrees. Okay. So now I have an equation for side length A. If I solve for A, I simply get 17.5. Again, you guys can check the algebra on this. You could cross multiply. That's one way to do this. But if it's a kind of a couple steps, pretty quick, you get 17.5 times sine of 49.6 degrees divided by sine of 57 degrees. That is side length A. And if you plug this in your calculator, you get 15.9. So that's the length of side A. And we can check the reasonableness of this. Is this reasonable? It looks reasonable. It looks like side A is the shortest length, and in fact it should be the shortest length because it's opposite to the smallest angle. The side with the longest side is opposite to the largest angle, so that makes sense. This seems to make sense reasonably. And so now we've solved this triangle being an SSA triangle. These are two good examples of applying the law of sines to solve triangles. I will see you guys on Wednesday.